Hello friends, welcome you all once again in lecture series Manufacturing Technology. I am Amit Tiwari, Assistant Professor, Department of Mechanical Engineering, Suresh GyanVihar University, Jaipur. Today is the 31st lecture of Manufacturing series and the topic of the today lecture is Production of Metal Powders with respect to history. So the objective of the today lecture is to understand the basic of powder metrology progress. Second is learn about various metal powder production methods. Third is know the different steps involved in powder metrology part preparation. Fourth is understand the advantages and limitations of powder metrology. And fifth is learn other development in the compaction processes. And sixth is design parts for powder metrology process. So these are the objective of the today lecture, and we will cover all this objective today one by one. Outcomes at the end of this lecture, the student will be able to understand about differentiate manufacturing methods for the production of metal powders and discuss particle morphologies like size, shape, characterizations, understand the requirement of lubricant and blenders. So we're discussing the first point, that is the sintering. Sintering means the heating of pressed compact to below the melting temperature of any content of the compact, or at least below the melting point of all the principal constants of the compact. So basically, in the powder metrology, the stirring is the most important method which we are follow for maintaining the quality of powder by means the heating of pressed compact to below the melting temperature or any constitution of the compact, basically. So at least below the melting point temperature of all principal constituents of the compact, so that we have to maintain the temperature below from the melting point. So this is the same requirement of the sintering process. Such heating facilitates bonding action between the individual powder particles and increasing the strength of the compact. So there are such conditions will be obtained that are, we can say that some bonding actions will be facilitated between the individual powder particles and increases the strength of the compact. So the heating is carried out in a controlled, inert or reduced atmosphere, basically. Or in case we can say it is a vacuum to prevent oxidation. So the prior to the stirring, the compact is brittle and its strength. So known as to be green strength as is low. So generally, sometimes it will be also known as the green strength, because it has a prior to stirring and compact is brittle. So that's why the strength will become known as the green strength in low. And the nature and the strength of the bond between the particles and hence of stirring products depending upon the mechanism of diffusion plastic joint, or we can say that the evaporation of volatile material in the compact. So the recrystallization growth or grain growth and pure shrinkage. So during the shrinking the process, bonding of the individual powder particles take place in any art, and the melting of mirror constitute diffusion, mechanical bending, etc. So this type of stirring process are constitution individual powder that will take place in the three type of ways. The first is melting of the mirror constitute. For the melting of the mirror constitute, that means continuously heating of material of a powder in a certain temperature that is below to the melting point of that particular material, and continuously using the constituents and a different type of diffusions parameters to be selected for the process have to be maintained to check the rapidly after some 10 to 5 minutes, so there is something changes or not. If there is no something, then continuously will be operated for that. and the mechanical bonding. The mechanical bonding, that means it has to be occur and it has to be diffusion, that we have to understand to strengthen the material very high. And if the strength of the material is not very high, that means it will weaken inside and it not capacity to bear the load, because we know that for high strength we require for any operation, any machine, you have to bond any part, any component of the machine we have met, that is the requirement of the high strength, because we subjected to the very high stresses are occur on that. So for maintain this all the stresses and for maintain the straining, means that the heating of the press or to be contact below the melting, that will have a temperature of any constitution of the compact very less. And the constituents of bonding required between the individual powder particle and increasing the strength of the powder particle. And heating is carried out in the controller. So that's why we can say the inerted or reducing in atmosphere having. And in the vacuum of preventing the oxidation and preventing to the starring. So these are the complicatedness of the material which having the strength of very high. So known as the green strength and its production that be depending upon the mechanism of diffusion. So there are some type of mechanism which are depending. The first mechanism, that is the mechanism of diffusing plastic flow. Diffusion plastic flow is the first mechanism. Second is the evaporation of a volatile material in the compact. And the recrystallization, growth, cane growth, and the pure shrinkage is to be observed. So during the shrinkage process, the bonding of the individual powder and particle take place in the any part, which will to be observed by the melting of a mirror constitution diffusion and the melting of the bonding here, which are to be joined together, having the combination which is to be used for that. So the powder particles, you first of all identify that the quality of the powder particle, that means what type of quality you want to increasing first of all. If you want to that particle to be increasing and you have idea what substitutes you have to add for increasing that particular property, which is the responsible factor of that. Then you have to just select a powder. Yes, this type of property will be increasing by addition of this. But if you have to identify that your property will not be matched with the other, it will be sometimes you have to lose the property. As maintained, we require more. So the prior to the stirring, we understand the first point it is. And the compact is brittle and its strength. Known as the green strength, basically, is low. And the nature and the strength of the bond between the particles, and hence the stirring product and depending upon the mechanism of diffusion, basically. And evaporating of the volatile, or we can say the metal in the compact, or the recrystallization. So these are all the types of bonding which we are using, that we have to maintain all the criteria for powerfully. And individual power particles take place. So melting of the mirror, that will melting of the mirror and the constituents depending upon that. And we can say that the such heating facilitated bending or between the individual powder particles to be increases the strength of the compact. And heating is carried out in a controlled inert or reduced in the atmosphere or in a vacuum to prevent the oxidations like that. So this we can say that the prior to stirring and a compact brittle, having the heating of pressed compact to below the melting temperature or pressure of any constitutions of the compact, or at least below the melting temperature of all the principal constituents of them. So these are the some reasons to be identified why it is a very important as compared to this. So these are the some reasons which we have to use for increasing the mechanical or increasing the chemical property of the powder particles to be stringly bond are to be generated very high. The strength will be generated very high. That will be required. This is the main our requirement. Why it is useful for. So during the stirring process, the bonding of the individual powder particles take place, that have to be and understand the three type of way: melting way or minor way or constituent way. So this type of a mechanical bonding, diffusion bonding, and the melting of mirror constituents are the responsible of the stirring process. Yeah. Okay. Next one, that is the important factor which control the stirrings are. So the factors are the temperature, time, furnace atmosphere. The stirring temperature used vary with the compression load used and the type of powder and the strength required for the finished part. So we have to decide that the important factor which control the stirring are temperature, time, furnace, atmosphere. Because temperatures to be required, we have to check the temperature range, what the time required for particular hours, and for the furnace temperature also we have to maintain, because if the too much high temperature increase, then the particles will be burned and it will be disadvantageous for us. So for preventing this, to maintain the furnace temperature. So the stirring temperature used vary with the compressive load used, the type of powder, and the strength required for the finished part. The aluminium and the aluminum alloy can be stirred at temperature from the 350 degree to 500 degrees Celsius for the period upon the 24 hours. Copper and copper alloy can be stirred at a temperature ranging from the 700 degrees Celsius to temperature that may be melt or the constituent metals basically. And the compact of the iron powder are usually centered at a temperature from the 100 degrees Celsius to 1200 degrees Celsius for approximation of half an hour. And we have to decide that during the sanitary ordinary, the density of the compact is increased and shrinking results. So the shrinking fills the holes within the compact, increasing the area of contact and the reducing the size of the hole in the compact. So both are shrinkage can be controlled by the careful product and have to be measured at. So the what we can say that the copper and the alloy are strained at a temperature range from the 700 degree, that is the temperature for the metal the constitutive metal is to be used for that. So these are the important factors which we are controlled by the signature, that is the temperature, time, or the furnace atmosphere. And the sanitary temperature which have to be required vary with the compressing load that is used with the type of the powder and the strength required for the finished part. So these are the some part to be used for the aluminum alloy can be standard and the temperature from the 350 to 600 degrees Celsius for the period of 24 hours, which have to be a standard time which we have to maintain for. The copper and can be strained at a temperature range from the 700 to, we can say, that melting from that constitute metal. And the third one, that is a compact of iron powder, that is here. For the iron powder, usually we strain at a temperature from the 1000 degrees Celsius to 200 degrees Celsius for approximation half an hour. So that time the stirring will control. So that time the stirring will control by the three zones: temperature, time, and furnace atmosphere. During the stirring, the density of the compact is increased and shrinkage result. The shrinkage fill within the hole, we can say the compacts increases the area of contact and reducing the size of the hole in the compact. So the shrinkage can be controlled by the carefully. So these are some benefits we will get out. So this type of technique which we are adopted for maintain the temperature of furnace and by the temperature by the time and the atmosphere for furnace. So the furnace temperature depending upon the what type of metal we have used from the furnace. The aluminum material that we have to maintain the 350 to 500 degrees Celsius. Copper that will 700 degrees Celsius, and the iron that is 100 to 1000 to 1200 Celsius. And these all are very, we can say that is all a very important factor which were affected. And during the scanning, we have to maintain that. So the density of the compact is increased and shrinkage results. So the shrinkage, the filling the hole and within the compact and increases the area of the contact and reduces the size of the hole in the compact. Shrinkage can be controlled by this whole other factor which we have. So during the we can say the copper and the copper alloys and the staining and the temperature changing from the 700 degree is the range from the copper, and you have to maintain this by the maintaining the furnace atmosphere. Now you can see that the diagram in which the selection of the metal powder and determination of the correct pressure for cold forming. Instances are also made when press compact grow during the staining, and this is caused by the grace build kept within the compact during press or produced by the chemical reaction within the compact. And the indications figure that quantitative effect of the staining, temperature of the density of pressed metal powder. So as you see in the diagram, that is the theoretical density of the solid metal. It is the theoretical density of solid metal in the upper part denoted by the dotted line. The graph between the staining temperature versus the density, that is percentage of the theoretical. And in which you have to say that a 3 para, that is the first is powder press at low temperature basically. Second, the powder press at medium pressure, and the third, that is the powder pressed at very high pressure. And this is the melting point in between this. So what we learn from this diagram, that is when you have to increasing the pressure on the material, solid material, then the melting point will be increasing, and it will be chances that the before the timing it will be melt. So that time we have to know that how to determine of the correct pressure for the cold forming is the other requirement. Instantaneous are also made when press compact grow during the staining, and is this caused by the gas being tapered within the compact during pressing or produced by the chemical reactions within the compact, and indicate the quantitative effect of the staining temperature of the depressed metal part. So these are some requirement basically. These are some basic requirement of us, and these are the selection criteria which have to be used for. These are selection criteria as per the range. The power pressed, that is the low power pressed required. Another one is medium power, and third one is the very high pressure. So it is depending upon the conditions occur. It's just depending upon the conditions occur. What conditions are to be used for? For this, we require the such type of parameter we have to use for that. Have to be easily to maintain. So the theoretical, or we can say some density of the solid metal to be used. It is to be used the power pressed at the very high pressure required, and the powder pressed at the medium pressure to be required. Now it's time to understand how the selection of the metal power and how to determine of the correct pressure for the cold forming. Which what pressure the cold forming will occur, what pressure the cold forming does not be occur. So instant are also made with the when the press contacted grow during staining, and is caused by the gas being trapped within the compact. During the pressing, or we can say the producing by the chemical reaction within the is very important. indicates the quantitative effect of the stirring temperature on the density of the pressed metal powder have to be required for that. Density occurs basically. So these are the some temperature basically required during at the melting point. So when you increase in the temperature, that is to be nearest come about the melting point. Okay. So that time you have to understand that these principles. It is not observed by anyone. So that time we have to understand that this criteria to be selection very important and this criteria selection not very important. So you have to maintain all this type of factor that is powered by elasticity. Or powder press has to be low temperature or high temperature, you have to maintain. So caused by being the trapped within the compact during the pressing and produced by the chemical reaction within the compact. It indicates the quantitative affecting of the stirring temperature or the density of the pressed metal powder to be used. So these all are the some category selection of metal power and the determination of the correct pressure are to be called commonly used. Instant and also meet when the pressed compact grow during the stirring. So this is caused by the gas being trapped within the compact film and having the idea. Third one, that is we can say that stirring may be carried out in batches or continuously in batch type and continuous furnace respectively. So batch type furnace prove useful for laboratory or experimental work, while continuously furnace are more suitable for the production work. And the continuous furnace usually comprise the three zones. That is the first zone warm, the press part. The protective atmosphere is in the furnace plug, the work by air or by oxygen that may be carried within the furnace by work or dry. Or in the second zone, that is the work is heated to the proper stirring temperature. And the third zone cools that the work of the temperature that allow the handling and shows a continuous conveyor type stirring. So these are the continuous furnace, usually the compressing the three zones. The first zone warms the pressed part and the protective atmosphere, having the base type furnace to be useful for the power laboratory and experimental work. So which continuously furnace are more suitable for the production work. So that time we have to understand that the stirring may be carried out in the batches or continuousness with the base type or the continuous furnace type. So these are some requirement of basically nowadays. That is why we can say that the continuous furnace is usually comprising this three zone. And the first zone indicates the warmth, the press of the part, and the protective atmosphere from the used in the furnace phases. The work of any air and the oxygen that may be carried into the furnace by your or trace. And in the second zone, the work is heated to the proper stirring temperature, and the temperature zone, third zone, that is cool the work to the temperature. So that also handling for that. So this is shown as the continuous conveyor type stirring by furnace. And having the reputational idea that you know that is when you are increasing the temperature, when you are increasing the furnace, that you know that the material if burn more excess amount, then it will be destroyed the part, or we can say burn all the components of continuous elements in between the parts. So it gives our disadvantages if we do this like this. So for preventing of such type of problem, we have to maintain the temperature between zone. And this zone are divided into three categories basically. So we already discussed that. So the first zone, that is indicate the warm the place part and protective the atmosphere used in the furnace plug, the work of any air or oxygen that can be carried into furnace by work or dry. So surrounding all the types of furnaces are available, but the condition is that first zone warms the place. That is the requirement basically. After that, the secondary we can say that the work is heated and then the proper stirring of temperature be selected. Then it will be maybe successful part. Third one, it is the third zone, that is we can say cool the work to a temperature. That allow the handling figure shows a continuous conveyor steering temperatures, etc. And it will be helpful for us how it we can maintain. It will maintain by certain temperatures, certain zones. So as you see in this diagram, that it shows that a temperature controller, this is a temperature diagram steering furnace basically. You can see in this diagram that is a charge end, both side left and right. And the charge end, the upper portion here, that is the exhaust hot. And the right hand side charge end, the upper portion is hot only. And the gas atmospheric inlet are used for the atmospheric temperature get inlet from that what temperature in the atmosphere. So we can collect all the gases from the air side. Coding zone, that means you have to apply for the cooling and for the maintain the temperature, cooling zone. And this cooling zone basically operated by registers, heating zone, thermocouples, and the temperature controllers. And we have to use this type of electric furnace, that means the stirring furnace, used only for the powder metrology, not for the others. So this powder metrology is used for maintain the charge end when continuously movable, and we have to generate the electricity like this. So charge ending we have to use for that. And we have to collect for the again the cooling zone from both sides, left and right, to operate this system. And the heating zone or the exhaust zone is totally depending upon the input we have to supply for the machine, which are related to our atmospheric conditions or the financial aspects. Because larger the machine and complicate the machine and larger the value, definitely will work, but it no one will prefer because it will too excessive, expensive. The customer want to market attitude that our product is to be work as a very low specification, but a good quality. If you want to increase in the quality, that you have to decrease in the sometime the quality of the machine. So that is the some type of atmospheric electric surfaces to be used for understand the principle of steering furnace. And the thermocouple and the heating zone is suitable for to inside the temperature very high or warm you have been selected for as you desired. Depending upon that, yes, this type of operation will be performed it easily, and is it not performed, it is not required for us. So this type of steering furnace have to be now very popular and have to be used for the machinery every purpose. So there are you have to manage that how you can steering surface we have to use for that, and how the shocking zone and the glass flow that is we have to managing for us. So that time we have to decided that the material which are used for this is a very prototyping and having the idea of coolness. So there are some note that is the strength, ductility, and the density of power metrology part is much lower than the for corresponding parts. And the density is usually less than 90% of the density of conventional metal. Ductility vary from the perhaps the less than 0. It is 10% to 70% of the value for conventional metal basically. And for the conventional metal, we have to identify that the metrological part and electrical speaking, and also know that the poor corrosion resistance probably the cause of large area export by the pores of the object. And this shortcoming can be becoming a interpretation with the low melting alloy and the non-metal. So these are the some conditions which we are observing for that. So we have an idea, we have creating an image for a process. It is very grateful. And also compacting with the part from the word stroke. So what stroke is that is the strength, ductility, and the density of a power metrology part is much less than the corresponding etc. Density is usually less than 90% of the density of the conventional machine, vary from the 70 to 10%, 70% value for the conventional metal. And the powder metrology part, generally speaks, are known as poor corrosion resistance probably, and caused by the large area caused by the pores of the object. And this shorten can be overlooked by the impregnation with the low amount or in the non-metallic area. So basically this type of water metrology is selected for the different range, different area to be operated, and most of the time it is the conditions are different with them. And these are the conditions which will occur. It's not easy to path to be handled. Now some finishing operations are here, that is after the stirring. The additional operation may be carried out and to the further improve the property of metallurgy of products. The first that is a repressing. Repressing. So the purpose of the operation, also called cooling, can coiling, sizing, etc. So to import dimensional accuracy to the stirring part and to improve the part strength and the stress pressing by the additional densifications. So lensing the process, that means the forging is here. Three type of processes, that first is the pre-pressing, second forging, third is infiltration in the process metal, and fifth is the powder metal. So that's why we can say that the purpose of the operation is may also be cooled, not but it, to impact the dimension accuracy to the stirring part and to improve the part strength and face by the additional deformation area. So these are the overall that we consider stirring process. We have been discussing about that. The stirring is very popular. Why it is very popular? I think we have to understand all the features related to the stirring system. So I'm just reminding to all that is the powder metallurgy process require a number of processes that need to be carried out. And first start with the production of metal as or alloy powder we have to make quite position for the distribution. And the metal or alloy powder need and the metal or alloy powder need to be burdened with the suitable additive illustrations, lubrications. And throughout becoming a powder and additive sense, that additives are uniformly distributed, which would facilitate the compactness process later. This power pendant is launched in the die depending upon the press automatically by launch. And there is a number of compacting methods that can be used to be broadly classified or called home and hot diffusion. In order to this variation, these are the more precision processor that can be equally as the die less stretching, isoconnecting, extrusion, injection, molding, rolling, sleeve casting, and cold rolling, etc. to be performed on that machine. So that's a very important type of machine we have for selection criteria. So these are the some understanding phenomena which we are to operating in the cast element, which we reducing the strength of the of as compared to the same structure. But condition are different. That is the weight are heavy. Then first of all, reduce the weight by the stretching by the having. And if you can ask that you can cut all the parameters which are not affected by in the machining parameter that is used for the operation easily. So tell me what you learned from that. That is to be a part of for the industry. So as we have to idea that is the metal additives, bending, hop, camping, warm compound computing, steering manufacturing, steering finishing, and product manufacturing product basically. So these all are some fundamentals which we have decided to be what we are doing. So the metal power, additives and blending and hot camping and warm camping and cold camping. Studying the secondary and both are secondary in which one is diamond, second one is finishing product. So it is used to be a very high type of IV range of metallic additives to be observed. So this type of technique which we are observed, which have to be calculated for. We have to calculate for the reason that is to why it is to be important for that. So we have to understand that all the factors in the previous back if you want to say that it is stirring process here and bending process in the upper part. What we call competing or competing are the type of zonal I have to fix here. And only the two I think two that is the type of material is selected for this. The first is that is from the metal powder. It will be complete for use for that. And second one is steel. That is the steel which you have to use for that. So these are the some characterizations. These are some method which we are using. That these are the some participation which you have to adopt for the and have the real idea. Yes, what type of parameter you have selected is to be a classification of the metal which we are using for that. And having the criteria on to be fixed and having the criteria to be selected for secondary forming like this. And the product manufacturing completely and like the name, the product manufacturer is the answer for that. Okay, so I think we asked some multiple choice questions based on the powder metal system, which is the dimension accuracy in powder metallurgy. Options are that is A, it is higher than the another. Okay, second is the wastage of waste material in the powder metallurgy as scrap as. Second is large, small, depending upon the other factor, medium. So that answer is B, medium product. And we have to select for question number 3 is complex step can be performed effectively used. That is a powder metallurgy, turning, casting and metal casting. So these all are some funda which we adopted for that as it is to be a modified classification. It is to be a classification for us for that. In powder metrology, the range of the particles in about the millimeter and micron, that is 4 to 20, 0.3 to 0.003, 100 to 200, and 5,000 to 6,000 is the answer for that to be used for the unwanted expectations in the method. Another one question that is related for the press forming metal by causing molten dip metal throughout an orifice over the which is break into the small pieces and the break height is for the fluid pressure. So there are some conditions which we are operating for that, which we are resulting for that, which we have an idea how to get operating this. So these are some factors which are affected for machining operation which we are not related with the. So atomization and reduction and crushing and atomization, these are some breakdown of the material. There was a large amount of. We have to not require breakdown of metal. We have to require only large amount or small amount of metal to be selected for this. So these are the some techniques which you have to be adopted. This is the soul of of having the idea which has to be going to take for us. Third question, the next question, that is the formation of metal powder to use in powder metrology by producing compact, we can say that trio or other is known as the atomization, reduction, crushing, electrolysis. The options are that is B, reduction. Seventh question, that is the production of powder, pure powder of iron and copper can be effectively done using atomization, reduction, and crushing and electrolysis. Electrolysis is the answer for this. It to be used for it now. Eighth question that is related to the powder of various and non-ferrous metals which become the brittle fitting can be formed usually. Options are atomization, B reduction, C crushing, and D electrolysis. So these all other terms will be able to calculated by the different type of method, different type of observation, different type of capability we have to use for that. So all the criteria we have to understand for making the effectively video for to analyze the brittle of heating and maybe form using that. That is crushing, the right thing. Ninth is stirring is due to basically to increasing the final step, decreasing the final step, initially increasing and then to decreasing the strength, and initially decreasing and then to increasing the strength. Both conditions are should to be applicable for the stirring is done, but for the aid it's a final initial state. So the final, that is the speed of this string, that it is the initial state. So these are the some parameters which we observe for making the series, and you have to shoot an idea about that. The last question, that is a part produced by powder metallurgy is termed as. Options are A, wallet part, welded part, B, cast part, C, forging part, and D, stirring part. And the next, that is a D, is the correct answer for that. So these are the some recommended books for that is the for principal manufacturing material process by James Campbell, Tata Magazine publisher. Second is the manufacturing technology foundry forming welding, MJ Jao by Tata publisher. C, that is production engineering science by PC Pandey and C, casing by Stanton publisher. And fourth, manufacturing technology by R.K. Rajput and Lakshmi publication. And fifth in manufacturing technology by P.N. Rao and Lakshmi publication. Matatagli publisher. So these are the publishers related to the manufacturing series. So you will contact to me on my email ID. I hope you enjoyed this video. You will contact me my email ID at amit.tiwari@my.com, and you contact to me also on my mobile number. It is 8690319448. I hope you enjoy this video. Thank you so much for listening patiently. Thank you for this video.